Hey guys, it's been a bit. Um, I haven't really uploaded anything substantial since just been uploading really random videos and stuff. But either way, today we're gonna be talking about something new in Blender 3.0 that I don't see talked about a lot, which I believe has a big implementation that should be coming in the future, and it's actually something super exciting, at least for me. So we all know about well, what we all should know about Houdini's switch node function, which allows you to switch between different sets of geometry or really anything, nerves and stuff. Um, Now Blender has its own switching in using geometry node. However, it's not as in depth as Houdini, but we'll see what we can do with it. So let me give you a quick example by bringing in Suzanne and bringing in a cube. Let me split the window here, set it to geometry node. Now I want the cube to be the main object, the first input. So I select the cube and add a geometry node network. Now if we add a switch in utilities, utilities switch, uh, we just add that in and toggle, we see the cube disappears. We take if we take this boolean, which we can animate inside of geometry nodes, but I prefer to take the boolean, which by the way, if you don't know what a boolean is, it's basically a 0 to 1 function, true or false. Um, when we add it into the group input, you can see we can now manipulate this inside of the modifier tab. Switching this from 0 to 1, since we have nothing on the other output, just basically makes our geometry, our cube disappear. Our cube is still there. If we go into edit mode, we see that, but it's not registering anything in the world. Though it does keep its physics property. So if say you have rigid body collision on rigid body dynamics on this cube, it'll still respond, just won't appear. Um, so let's see. We have Suzanne here. We could, if we hide Suzanne, we want this cube to switch between the cube and Suzanne. So let's grab a input object info, find Suzanne, and set the geometry into true. Now, when we switch, we get Suzanne. However, this, if I go to the new spreadsheet and switch this to instances, we see Suzanne is being instanced into the scene. So she isn't actually in like a geometry. If we, in fact, if we hit tab, we see we still have our cube. We can scale the cube, nothing happens. Um, but we visually, if we go into render view, we see Suzanne. Now, I don't know about anyone else, but to me this is exciting. Uh, However, one limitation that you'll notice off the bat is that you can only go between 0 and 1, meaning you only have two states you could be in, unlike Houdini, which you could have multiple states. However, this panel here on the modifier geometry nodes tab kind of gives me the indication that there will be more more numbers or more states of switches. How will they implement that? I'm not sure, but I hope at least that that's part of the plan, because that would make things a lot easier to manipulate. So now, one of the reasons I'm gonna say I not to use object info is that you are limited to one geometry. One one Suzanne per scene. So what if you want a something more complicated, something with multiple parts, multiple objects? So say let's add a cone and give her a little hat. What if we want this? Now we can't we can't use the same object info because we can only pick one. Now what we can do is do a join geometry, pick the cone, join them both. I'm pretty sure that's backwards, but I don't think it matters, and put it in. But you'll see we have to switch it to relative, and even then it's a bit wonky. So what do we do? Well, what we can do is grab both the Suzanne and the cone and put it into a collection. What you call this collection doesn't matter. Hat monkey. Not hate monkey, sorry. Hat monkey. I can't spell. Uh, and we can actually disable this collection. Now, if we go to input collection info and put hat monkey and pop it in, we see we get both of them. Now, we'll see that by toggling on the hat monkey collection and turning it off, we see they're the exact same position. By moving the cube up though and moving in a different area, they also move. So they are no longer in the same position unless you switch to relative. At least that's what I've found so far. So all in all, this new node, this simple node, can be used for many different things. As you see, we have float, integers, boolean, vector strings, colors, object, geometry, and collections. However, I like to keep it to geometry and use this this method of just for a bit more control here. We can add in a transform and move it around independent of its original state. Give it a bit of, maybe add some animation, some drivers, as you wish. And you'll find plenty of uses for that. However, once again, we run into the issue that we can only have 0 and 1. So we only have two states, and we'll get to that later on. Alright, and here we have our first example project involving switching an object that temporarily goes out of the camera view through this hole. We see turns into a cone, a rounded sphere, and to Suzanne only to go back into a sphere and loops again. Now, this is one instance of geometry nodes, and similar to like hiding and animating stuff in the hierarchy view here, it's you will have to animate each and every parameter on its own. So like so hide sphere, show cone, hide cone, show rounded cube, hide rounded cube, show Suzanne, and then back. Now, if you remember, I told you that we couldn't show more than one Boolean input for the time being on the switch node. So a way I got around that was to in fact have multiple switch nodes overriding each other. There is probably an easier way to do that. I am not geometry node savvy, but I managed to get this is simple enough to keep track, and as long as I don't have an overwhelming scene, it shouldn't really be that hard. So each object has its own collection. All objects in that collection are parented to the main object, which is the sphere. And that sphere has an animation that moves it up and down and spins it a bit, which, because of parent-child relations, all the other objects also do the same in their own collection. However, all geometry nodes is doing really is saying, okay, hide the original object and instance this other collection, which is doing the same exact animation. Now you could obviously get more complicated than this. You could do a bunch more things. Even particle systems get instanced over. Uh, However, this is a simple bare bones example of instancing and switching, which can be useful for certain projects, and just looks cool in general, seeing it in a loop, seeing it go weep whoop. So if you're curious as to uh, how easy it is to set this up, here is the keyframes. So we see here all keyframes start at 0. At least that's the way I did it. Obviously, more than one ways to do things. We keyframe 0 to switch to 1. This is the first object switching, which then, when it goes back into hiding, switches back to 0 and switches the other one to 1. This is all manual, so it would be like animating the view scene up here, but instead you're doing it all in geometry nodes. It's much more modifiable since it is a modifier. I would also like to point out that you can't really animate these collections. So the only way you would be able to animate that is to add a driver to a separate object, connect that driver into the the every object that's inside of the collection, and hide it, because this check mark cannot be animated, or you can't add a driver to it. These other ones, the other buttons, you also can't add any, but everything inside that collection can be, or they should be, animatable. Yep, here it is. So you can insert keyframes on the viewport visibility and the render visibility, but you can't on the collection. So what this allows is something much easier than we had before to reveal entire collections without having to just add drivers and such. Much simpler, much cleaner. Uh, yeah. So next example, we'll show another instance of switching. So here we have another example. This time I've brought in certain assets from Sketchfab to make things fast. They're pretty low poly, but they get the job done. So here we have a standard scene. I didn't really do much on the lighting, but that's just to it's just to show something, like if you're presenting um, a product. Now the camera does a little thing where it spins on the back and switches, revealing another object. Switching reveals another one, and then switches back. Now, this was once again achieved using the same technique as before, just basically showing you that this can work on much more complicated geometry that are just in a collection. In this case, this first statue is one entire geometry. However, once we get to the second one, we start to see, it should be this one, that it is in fact multiple uh, geometries. We have the main character here, and then we have the stick. Not that complicated, but it shows that it still has multiple geometries on it. And then we have the final one, which is this World of Warcraft, which does have way more geometry than the other ones by comparison. More objects, I mean. And all of them instanced with geometry nodes based on this first statue. Now, keep in mind that this is done with the same method, switching. Also remember that I kept the same original positioning for each one of these, so they're all overlapping on each other. This just makes everything easier. You want to be thinking ahead. Uh, if I want the one of these statues to move, I would have to go into the collection itself and move it to the side, hide it, and then you'll see that they it moves it to the side. Now, in this case, this particular effect, I wanted all the statues to be replacing each other. So let's keep it at that. And this is good for certain reveal projects. Now all I would have to do is go into this statue, change the collection that I want, or maybe I want multiple collections to appear. I don't really know what you want, so it all depends on what values, how deep into geometry nodes you want to get into. Hey guys, so now we have this example scene of a pre-fractured skull being smashed by a cube. No, it's already been baked, already set up, but nothing too complex, nothing fancy. This skull was self-fractured by using the self-fracture add-on, which comes with Blender. However, I do recommend getting this add-on called RBD Labs, which makes the entire process a bit more streamlined to self-fracture something inside a Blender. If you now when self-fracturing something, it's always handled slightly differently in every program. Houdini handles it differently, Maya handles it differently. Blender obviously is going to handle it differently, and to be 100%, it really needs some love and care because it takes a lot to properly get something out of Blender self-fracture. Now, I don't I don't hate the self-fracture add-on, but it does leave a Voronoi like appearance. It takes you need to mess with it to get, smaller geometry. You still get, no matter what you do, you still get like this Voronoi like look. There's no jagged edges and stuff like that, which is why I prefer the fracture modifier branch of Blender, which you can find in the experimental build. However, self fracture does have its uses. It's a lot easier to do, in my opinion, and you don't need to be switching from Alembic and transferring over back to Blender 2.9, which can be a whole pain in the ass. Now, uh, that being said, why do we need the switching node for this fracturing? Well, when you self fracture or when you really fracture anything, um, at least so far that I've seen, it's always a pre-fractured model. So every model you've seen break is already broken. However, you don't know that as a viewer. You when you see the model before it gets broken, it looks intact. It looks non-broken. So that's why it's really not that great when you start to see this. I hope YouTube compression doesn't cut this out. You see that the more complicated your geometry is, the more fractures, the smaller pieces you have, the more likely you are to see pre-fractured seams. So you can see this here in cycles, where at the top of the skull you see the cracks. You can get away with it with the front a little bit more. So if I had the camera down here, I can get away with it. But or if I say I needed the camera angle to be up here, my audience would see that this is already fractured. This skull is already fractured in a way for it to break exactly like this every time. Uh, now I'm not. Now, yeah, there's ways to hide it. There, you can add an empty, and based on the empty's visibility, you can animate. You could add a driver to hide every single skull piece, and every debris, and but that would take a lot of time, and honestly, it's a bit of a pain in the ass to do. Now, with every cell fracture, you still get to keep the original skull. Now, this is the original skull that has not been moved. It's pretty important that you do not move it from the location that it's been fractured. If your skull is animated, such as like it's falling with rigid body, you want then to self-fracture on the last frame before you're like on contact with the ground. That's when you want the self-fracturing to happen and the rigid body dynamics to take over. How you do that is up to you. So either way, this concept stays the same. We want this skull to switch from this one to the fracture. Now, obviously, this means that we need this skull's collection, which if you use the cell fracture add-on, you can have it all the pieces be placed automatically in a collection. You just need to let me actually show you. I go to Object, Cell Fracture. You can see right here, Scene Collection. You type in your collection name, press OK, and it'll do its fracturing business. However, this isn't a fracturing tutorial, so I won't bother with that. It's a little bit of a hassle to deal with. So now let's open geometry node. So we obviously want this skull to be our main skull. This is where we want the switch. Now let's add the geometry network. Add utilities switch. Put in the switch here so we can see it in the modifier tab. And now we want input collection info and find the skull. Now you're going to see something weird. Our skull bumps up. It looks like the sun is in the collection as well, which is not what I want. So I'm going to change this to another collection. My bad. Easy fix though. So we see that the skull jumped up. It's not in the same position. Just switch that to relative. Usually that fixes. If not, you will need to add a transform node and manually try to get it as close as possible. Usually it's offset by a -1 on the Z or a -1 by the X. Depends on your orientation, I guess. I don't know. So we see we're now able to switch. Now this is where it's important that your skull has already been baked. Like it's rigid body dynamic, you're done with that. This isn't about rigid body dynamics or particle simulation. That's already done, it's already baked once you get to this point. So now you see the skull, the switch skull, carries over that fracturing animation and it appears on render with texture and all. So now it's as simple as animating it from the point of breaking. So when it first starts to break here on contact, we set a keyframe, move back one frame, set it down. We see that it's pretty average. Uh and did I not add a keyframe? I didn't add a keyframe. I may be a little bit of a dumb, but it's okay. 'Cause you sort of love me, I guess. If you're watching, if you're hearing this for this long. So we see regular skull, contact switches to fractured. What does this solve? You can no longer see the seams up here. The fracture seams, you can't see them anywhere until the point of contact, in which you all want to see those fractures. This, of course, also is an instance, meaning that's pretty fun to watch. It's an instance, meaning it's not adding to your scene. It's just showing from another point of your scene to this point. It's basically it's nothing. It's not gonna add to your render times. Your render times generally will stay the same either way. So here we have something very useful. I have already used it for a couple of my renders just to test this out, and it's a time saver in terms of not having to add an empty node, an empty object, and have that connected to a driver, so that when I turn off the visibility of the empty, it turns off the visibility of the collection. Blah blah blah. And this is just a lot easier. Alright, so here is some little interesting stuff that I found about geometry nodes while just messing about. So in this scene, we have two boxes on a box, but let's call it a plane. Um, and they fall on top of each other, one box stacked on another. Now you may think that if since I'm changing the geometry, switching it, so we go to utility switch. If I connect nothing on this end, that means there's nothing for to collide. The collisions are will be void. So if we see that, switch, still floats. Why? Well, because the object is still technically there, according to Blender's collision and rigid body system. Now, let's see if I animate this to disappear. Would this cause anything? Nope. That's due to, well, it's still technically there, according in Blender's eyes. Nothing has, it's only disappeared from your view. It's still there. Which means that if I were to, let's delete this and put this on top here, we still see that it falls and interacts. It does add behave a little bit wonky. But I think that's because I switched to edit mode. Yeah. Which is weird. But it doesn't, it still behaves like if it's still in the scene with its own collision and such. It doesn't behave like a ghost, essentially. Now, if you want that type of thing to happen, they still haven't added physics, or the whole physics panel here to be editable by geometry nodes. However, you can you animate it through here? Well, I'm not gonna stick around to find out because, frankly, that is a lot of me having to press buttons and check about. Now, what if you might be wondering, what if I were to add a geometry here? So say we bring in Suzanne the monkey and add a object info node, plug it in, pick Suzanne, and switch. Now you might think, oh, Suzanne, her collision is different from that of a cube. So obviously that might mean that this reacts differently. No, that's because to Blender, this is still a cube. So you're only really instancing Suzanne. As I've shown you before, if we go to the spreadsheet, to the instances, you're only instancing Suzanne. She isn't actually there as geometry points. Now, I did find something interesting where if I add an attribute fill in between, you see she disappears from the instances and is now in the mesh. That means that every point here is a mesh. However, her collision doesn't update. Now I don't know if there's a way to update this. Maybe. Oh, that kind of makes everything unstable, but it still acts like a cube. It doesn't deform. She doesn't fall over. It still acts as if that cube is there. Now, there might be a way to make Suzanne basically her geometry to affect the rigid body dynamic outcome, but I wouldn't know that. Now, another thing you might think is, okay, maybe I don't want rigid body dynamics to affect my scene, but I want what I want is for let's bring back the cube first so I could bring back my train of thought. For Suzanne to explode with using the quick explode function. So if we were to object quick effects quick explode, actually let's move this to frame 20. Objects quick effects quick explode, we'll see she explodes. Now if we go here, add a collision to our ground, since these are technically particles, Suzanne particles, that are causing her to explode, we need to add a collision, not a rigid body. Add a rotation just for the heck of it. And we see nothing particularly interesting. just Suzanne the monkey blowing up. Now, if what you might think, okay, if I were to add Suzanne to this cube, then all should be well. She does the same animation, but you start to see since she is in a higher position than the cube, her animation falls short. And that goes back to this is an instance. It's not its own physics system. It doesn't have the explode. It's just copying whatever this is in the moment this is in. So what do you do to fix this? Well, if we go back to the cube, select the cursor, move it there. This should fix it where Suzanne is now on top of the cube in the same position based on its origin, giving the illusion that these pieces are bouncing. If we were to toggle on and off, we see they're in the exact same position. This just shows that particles and functions like the explode do carry over. If we bake this, it'll be the same every time, and you can use this for instancing reasons. It doesn't really save you on memory because it's still exploding. However, it doesn't add to your memory, to your final render times. Now, there's not really a lot of reasons you would want a cube to switch to a Suzanne model and explode, but it is something that shows that you can have something with particles switch and still show in an instance from something that doesn't have particles. Now, obviously, this is just the beginning of what you can do with the switch function. If they add more numbers basically, then all that thing that I did with adding more switch nodes in order to get multiple geometries will basically be condensed into one. You could do a lot more things. Obviously, if they add more physics function into geometry node, more dynamics, you could add that too. But currently, this is what I've found so far in my time experimenting with it. Most likely, you can do a lot of other things. I haven't been able to figure it out yet, since once again, I am not that savvy with geometry nodes. But if you do, share it with the class, and that way we can all have fun with this together. And that's gonna be all. I don't know if I'll continue uploading things like this. I just found this kind of thing to be interested. If you're interested for a self fracture tutorial, just tell me about it, I guess, and I'll consider it. Peace.